Pair of parallel gears consist of 24 teeth pinion rotating at 5000 rpm, supplying 2.5 power to a gear. The speed reduction 4:1. Normal pressure angle and helix angle are 20 and 23 respectively. Both gears are made up of hardened steel SUT 750 Newton per millimeter square. Service factor is 1.5. Factor of safety is 2. Grade for gears accuracy. First, initial stages assume velocity factor accounts for the dynamic load and the phase width is 10 times the normal module. Assuming the pitch line velocity 10 meter per second, estimate the normal module. Select the first preference value of normal module 8. Calculate the main dimension of the gear. Determine the dynamic load using Buckingham equation. Find out the effective load for the above dimension. What is correct factor of safety for bending? Specify the surface hardness for gears assuming factor of safety of 2 for wear consideration. CW 1.15 for gears immersed in oil continuously lubricated. Wear factor is 1.25 for sand lubrication with frequent inspection. 1.35 for indifferent lubrication. Specify the surface hardness for gears assuming factor of safety 2 for wear consideration. First of all, we calculate torque, that is 6 into 10 to the power 6 P in kilowatt into power upon 2 pi Np, where Np is the revolution per minute. So we will get 4774.648 Newton millimeter of torque. Thereafter we calculate the pitch dia circle dia dp is equal to Zpmn upon cos psi. Psi is the helix angle. 24 mn upon cos 23. We will get 26.073 mn millimeter. Thereafter we calculate the tangential force Pt is equal to 2 mt upon dp, which is 2 into 4 is 774.648 upon 26.073 mn. So we will get the ending result as 366.25 upon mn Newton. Velocity factor of bath factor is 5.6 upon 5.6 plus under root v. That comes out to be 0.6391. P effective is equal to CS upon CV upon tangential force. Effective force is equal to CS upon CV upon tangential force, where CS is a service factor, CV is a velocity factor. 1.25 is given service factor and 0.6391 is a velocity factor. So we will get 859.61 upon mn as P effective. Virtual number of teeth on helix gear is given by Zp upon cos psi, 24 upon cos 23, 30.77. From the table of Bandari data design book, we will get y is equal to Lewis factor is equal to 0.39 for 30.77 number of teeth. Now we will calculate sigma bending, which is sigma ultimate tensile strength by 3, that is 750 by 3, 250 Newton per millimeter square. We know that sigma bending is equal to bending stress. We know that bending stress is equal to mnb sigma by, where mn is a normal module, b is a phase width, sigma b is a allowable bending stress, and y is a Lewis form factor. So we will get to SB as 975 mn square. We know that SB is equal to P effective into factor of safety. So 975 mn square, which is SB, is equal to 859.61 upon mn, which is calculated from the previous page, into 2. So here we calculate mn module as 1.208, and our first preference is 1.5. Main dimensions of gear. We know that mn is equal to 1.5, v is equal to 10 mn, which is 1.5 into 10 is equal to 15 mn. dp is equal to zp mn upon cos I, which is comes out to be 39.1111 millimeter, which is pitch circle diameter of pinion. Pitch circle diameter of gear is 156.44 millimeter. Effective load based on dynamic load based on Buckingham equation. Bending equation. Bending equation is mnb sigma b by. So that bending stress comes out to be 2025 Newton, and tangential force comes out to be 244.14 Newton. Now the next step is to calculate the dynamic load. For grade 4 error is given by 3.20.255, where phi is equal to mn.25 under root dp. So we calculate 1.5 plus 0.25 in under root 39.11, which is a pitch circle dia for pinion. EP is equal to EP for pinion is 3.96.9 μm. For gear, EG is 8.3226 μm. Also we have given C deformation constant 11 for 400 Newton per millimeter square. PT is equal to 244.16 Newton. Pitch line velocity is given by pi dp np 60 into 10 to the power 3, which comes out to be 10.24 meter per second. Now the dynamic force is given by 21b CEB cos square xi PT cos I 21 divided by 21b plus under root CEB cos square xi plus PT. Putting all the values in for velocity factor, for pitch line velocity, deformation constant, error, phase width and helix angle, and tangential force, we will get 1133.94 Newton for a dynamic force. Now P effective is equal to CSPT plus dynamic force, where CS is a service factor 1.5 into tangential force 244.16 plus 1133.94 1500.18 Newton, which is P effective. Now for getting the correct factor of safety, we will have sigma b bending equation equals to factor of safety into F effective or P effective. So we have 2025 as bending stress and P effective is 1500.18 Newton. So the safety factor comes out to be 1.35. For calculating the surface hardness, we have to equate the VS strength equals to P effective plus factor of safety. So that is 1500.18 into 2, that is 3000.36 Newton. Ratio factor is 2 ZG ZG ZP 2 into 96, 96 plus 24 is equal to 1.6. We know that Vs strength is equals to Vq dpk upon cos I. So that is 15 into 1.6, 1039.11 into 6.16 Bhn whole square upon 100. Here Bhn is the hardness of material, and cos case size I is a helix angle which is 23 degree. After calculating, we will get Bhn hardness as 420. So that is about calculating the helical gear parameters with the given parameters of helical gears.